Okay, so Tomra develops sorting solutions for various positions in the processing line, anywhere from on the harvester itself, and also anywhere in between and all the way to right before packaging. Why use a inline sorter, and what's our focus? It's to increase yield, is one of our main focuses, as well as food safety, and also reduce waste. Okay. And I'll get into a little bit of detail of how that's done. We have, as I mentioned before, we have various sensing technologies in our portfolio, and we use them differently for different applications. Sometimes the way we process a new application is we analyze it and we pick the right technology to address the problem. Sometimes it may take more than one technology to create a good solution. With these technologies, we're creating a certain property that we then use to sort the product. For example, camera, very typically used for looking at color, as it was explained earlier. But also it is used for looking at geometric information about the product, its size, its shape. For example, very typical to look for misshapen potatoes on whole potatoes, and so on. Or the picture I had earlier, gummy bears, looking for the gummy bears that are missing the head or something like that. Then we have laser. Laser is very good at looking for structure, as well as it can also do some color. Typical application is in the nut industry, for example, where the producer is trying to separate the kernel from the shell. Very often, they're exact same color. So we're looking for the structure difference, and normally using a laser. One way that I can explain it very easily is most of us have played with a laser pen. If you point it at a smooth wall, it produces a very focused point of light. Whereas if you point it into your hand, it disperses in there, and it almost penetrates your hand. And that's one of the big properties that we use to separate shell from kernel in the nut industry. Also, laser is one of the best technologies for identifying shards of glass in the fruit products. It's unmatched normally. NIR spectroscopy, Galen mentioned it earlier. We use that technology as well for sorting. We use it a bit different where, and he kind of touched on this, that Felix device is more of a measuring device, where an inline sorter is typically not a very good measuring device. It's a go, no go device where you either keep it or move it to a different lane. Those two technologies, inline sorting and handheld, like the Felix, are very complementary technologies. You could use them together. For example, you could use the Felix to find the right levels of solids, and use that to calibrate the inline sorting machine. Another technology that we use is the pulsed LED. It's effectively a low-cost solution that will provide a very similar image as a camera, but you can also add infrared. It's normally a monochromatic camera. We pick the right wavelength of light for that application. And again, it's a very low cost, robust imaging system. Then we use X-ray. We use that technology to sort items based on their density. Very typical applications would be, as Erwin mentioned earlier, looking for materials on nuts, rocks, and so on. But also for sorting stone fruit, pitted cherries, olives, and so on. It's very good at finding the ones that still have the remaining pit. And a later technology that we're implementing into our portfolio is the AI, artificial intelligence. That's available on some of our platforms, not all yet, but it's yet one more technology. Okay. The next slides are, I'm highlighting a few applications where these technologies work in. For example, one of them is sorting unwashed potatoes for the fresh market. As we all know, the potatoes are grown underground, so they're dug out. And then, so along with it comes a lot of foreign material. And it needs to be sorted unwashed, which is what poses the challenge. As you can see here, a lot of the potatoes are full of mud. These are fairly good in that they're not that exposed. Very often they're more exposed than that. And so you need different technologies to be able to sort through that. So here we use a multispectral spectroscopy. Okay. So here in the video, you can see it's targeting foreign material and removing it out of the main line. So the technology again that we're using there is multivariant spectroscopy. The way it works is the product is conveyed on this belt and falls off into midair and then inspected by the sensing unit. At that point, it makes a decision, waits for it to fall further in front of the paddles, mechanical paddles, which stay retracted if it's an acceptable product or extend out if it's a rejectable product. Okay. So we were talking earlier about spectroscopy, and I have a bit of a graphic here that helps explain how it helps with generating further contrast. Like for example, in this scatter plot, you can see if you see the green dots, that's acceptable samples of acceptable product, and the red is rejectable product. And there isn't very much separation between the two. You could make the argument that you could draw a line in between these two, but there is still going to be quite a bit of overlap. The way multivariant spectroscopy works is it helps, it does further calculations. In essence, you're able to see the data in 3D and generate further contrast. Okay. So here you can see an RGB image of rock, potato, rock, potato. So once it goes through our classifier, it classifies very, very well the foreign material, even though the color separation is not great. Another application is one we're very used to, or we know of well in this region. It's a processed tomato industry. We have uh, many, a lot of equipment in this industry. And one of the latest developments is the detection of broken and mushy tomatoes. There's two main ways of peeling a tomato, and that is with a steam peeling process or a chemical process, caustic. Um, the steam peeling process is much more friendly to the environment, but it's not as efficient to remove the peel. As well, when you put in a broken tomato into a steam peeler, it effectively disappears. Uh, and so that's all yield that's lost. There is some ways of recovering it, but it's still very costly as well. So it's important to find these broken tomatoes early in the process, so you can redirect them to a co-product, something that's already meant to be, let's say, paste, and don't send them to be peeled where for premium product. And this should be playing the video. This helps our customers improve the yield and productivity. Here you can see a video of a plant, a typical plant, and then first stage sorting, where they're just removing foreign material out of the flow of tomatoes. And then typically there'll be a second stage sorting still before the peeler, doing more of a quality sort, removing mold, off-color green, and sending those again for a different use, and letting the premium tomatoes, firm premium with the right color, go down to the peeler, get peeled, and further processed for a premium quality product. Okay. Just in general, the way this technology works, it's a very simple photosensor system, optical system. But the algorithms that it's using has been developed over many, many, many years. And that's how we're doing the sorting. Effectively, again, the product falls in midair, and there'll be two sensing units, one on each side, looking at the product from both sides, and joining those two images, creating one object, and making a final decision on that one object, effectively allowing you to sort by percent area. For example, let's say you are okay with 5% of your tomato have a yellow shoulder. You could do that because it's joining the two images. Okay. Another application is the Tomra 5X, which is an X-ray sorter. Again, Erwin spoke about previous experience with an X-ray sorter from our company. We've now come out with an improved version of that. It was released last year. Effectively, its biggest improvement is on higher resolution, and also the implementation of AI. So with the two combined, you can do a lot more. So we should look at that application again, Erwin. Yeah. This video that I'm showing you is of a pitted cherry, frozen cherry application, and where it's looking for embedded pits. Again, just a diagram of how it's set up, how the optics are set up, and how it's working. There'll be an X-ray emitter underneath the belt, where the belt that's transporting the product across it. and then there'll be a X-ray sensing unit above it, recreating the images and making a decision, a go, no go, or a keep or accept. And then coming off the belt in front of an air blaster, and then that will activate and blast the product out of the way with air, with a puff of air. Okay. Another application is leafy greens for our salads. We worked on a project with a major harvester manufacturer to produce a solution. They were getting too much foreign material into the plants. We already have sorting technology at the processing plants where they further package the salads. So here we're doing a preliminary sort on the harvester itself. Again, the very typical foreign materials are mice, field mice, and snakes. And so it's very good at removing those out, as well as rocks and mud and other foreign materials. Also plastics from the bins themselves, they'll put these into RPC bins and so the plastic breaks off of them as well. So it's very common to have these in the field. As you can see here, our leafy greens, they're grown very, very close to the ground, so very prone to picking up all kinds of foreign material. Okay. And again, this here is using a very similar technology as the one on tomato, where it's a photosensor array. Again, this needed a very robust technology that can handle this harvester going down the road, vibrating and hitting potholes and whatnot. Okay, and another application is the fresh produce. It was spoken about earlier today, and so this here is the product that's going to the produce area at your supermarket. This product needs to be handled very, very gently, and also inspected very, very closely. So the other systems that I was showing you earlier, depending on the shape of the product itself, the actual coverage or optical coverage of that could vary anywhere from 80 to 93% of the total area. So if you're trying to find that one little spot, those systems are not as good for that. This system, then you would need this system here. This system is rotating the product multiple times, looking and taking multiple images of it, ensuring that it captures every surface of it to find that one spot. One of the latest developments in this application here, as you can see, they're mandarins. Mandarins have become very common because they've produced a very kind of sellable product and very sweet, easy to peel. But one of its problems is that this product is stored, and in storage it develops or it propagates this defect they call it clear rot or sour rot, and it may be in a very small amounts when it comes in, but then it just develops and propagates in storage, and then further, if they process it and don't remove it, that will spread into the equipment and onto other product and propagate further, not just in storage, but in the processing equipment. So we have this pre-sorter that's looking at the product going into storage, looking for clear rots, as well as out of storage and removing it out of the line, out of the processing line early. And again, it's using NIR spectroscopy technology for that. Okay, just I don't have a video of this loaded, but effectively what you're seeing here is the protos is being aligned or fed by a conveyor onto the infeed side of the sorter. It's singulated into individual rows, and then it goes through a series of rollers here that it rolls the product to be able to inspect it multiple times, and then transferred onto an individual cup. So and then carried on until its final destination. And as you can see here, there's some exits, conveyors exiting transversely out of the sorter. And normally it's pre-programmed to, let's say, quality grade as well as size grade, and into different packaging lines. So it just waits till it's at its destination, and then a solenoid flips this over and gently transfers it onto that transverse conveyor. Okay, and finally, we have with these times, we've had to develop our digital solutions where we can remote support. We've added functionality to our sorter so we can remote support our equipment and get our customers going fast without having to travel as often. But also a product we call Tomra Insight, which is a data acquisitions product that takes all these different sorters are producing production data, and you can take this data and bring it into a central location, and we can display it to you and create information for you out of that data. You can get alerts on your phone. Let's say your defect rates have gone above your tolerance. You can create alerts that will let you know your defects are too high. Go take a look at what's going on. Yep. And also touching a little bit on how we develop new applications. Going back to a previous slide. We've developed different types of sorting equipment that are highly likely to that have the application in mind. For example, for grains, we have a different kind of sorter that will handle dry product, and for vegetables, we have equipment that will handle wet product. And so on, or cut product that has a lot of juices and so on. So we've developed platforms that fit most of the applications. But if you come with a new application that we don't have it proven, then the typical way is you'll come to the applications engineering group, and we'll do research for it. We'll see if we have a platform that fits your application. We'll run optical evaluation tests, and then also mechanical evaluation tests. Normally, we'll give you a report where we explain to you our likelihood of being able of having a solution for you, or any other options. As I presented before, we do have different technologies available, but they're not all available in one platform all the time. Then at that point, if we learn from our optical evaluation that you need this sensor, but it's not available in the mechanical platform that is suited for your application, then at that point we look at the market need, and And if it makes sense, then we'll design that sensor onto that different platform. That's all I got. Any questions?
Hi, first of all, thank you for your great presentation. Then my question is, how much accuracy these sorting devices have? Because usually when we go to the factories in the sorting line, we see there are some labors do the manual sorting after these machines.
Yes.
So I would like to know how much probability is for missing the bad products, and also how much is the probability of wasting the good products by mistake?
Yes. Okay, good question. The actual efficiency will vary with application to application. Most of our foreign material removal applications, like in nuts, where it's very typical, we can quote 98% removal efficiency of foreign materials. There are but foreign material there is a lot of contrast normally, especially if we are able to use the laser technology. There are other defects that are more subjective, and those it depends on the contrast that we're able to generate for you. What I've seen that is financially viable, it depends on the value of the product that you're producing, but there are sometimes benefits to having a sorting solution that'll only do 70%, and that's probably a worst case scenario. Our efficiencies normally lie around above 90%. And as we all know, sorting technology, getting that, let's say from 95 to 100%, we don't sell 100% efficient machines, just because of the nature of food and foreign material and defects. But the top percentage of efficiency is the hardest to get. You may throw another technology at it to get another couple percent, to take it from 97 to 98%, or 96 to 98%. And very often that's valuable to the customer. Sometimes it's not. I think we need to analyze the application. If it's a low-cost product that you're generating, and the main driver is labor reduction, then we need to look at less expensive solutions. If you have an application that is competitive, you have a lot of competitors, and you want to rise above with quality, then maybe a couple percent you're able to throw more money at it with more technology. So that's where we work with you to analyze your problem and what are you trying to achieve, and improve. And then we look at an array of solutions, and we build one for you effectively. Our equipment is modular, where this platform will take different technologies on board depending on how it's configured. What we typically do during the research, we'll run testing with different technologies and document the efficiencies for each technology, give you a report, and then you make a business decision if you're going to go for more technology or less, depending on the efficiency differences and cost differences. So it's a balancing act. Yeah. Very good question.